I'm Anil Kumar, and in this video we'll further explore quadratic functions in different forms. The question here is, describe two ways in which functions f of x equals to 2x squared minus 4x and g of x equals to minus x minus 1 whole square plus 2 are alike, and two ways in which they are different. So let me rewrite both these functions. The functions are f of x equals to 2x squared minus 4x, and we have g of x, which is equals to minus of x minus 1 whole square plus 2. Now, one way of course is that you can graph these functions, solve for x-intercept, y-intercept, and do so many things to find differences and similarities between the two. The other way is to quickly answer the question, right? So let's look for similarities first. Now, with the help of this video, I'll also explain you very simple examples, and I'll give you reasons which you could always use to write similarities between the quadratic function. One of the similarity between any quadratic function is about their domain itself. Now, what is the domain? So domain for any quadratic function given to us is x belongs to real numbers, right? So that's a universal similarity for your quadratic function. So don't think much about it. We only need to list two, right? So one is domain for you. The other one you have to really look for. Now, in this particular case, other similarities which we see is that there are going to be two x-intercepts. So the number of x-intercepts, we can say 2 x-intercepts. We are not saying they are same, right? But both of them have 2 x-intercepts in this particular case, right? This function, if you factor, you can factor 2x, right? And so you will get x minus 2. So there are 2 x-intercepts. Here the function has got a vertex at x equals to 1 and y equals to 2, and it opens downwards, and therefore it has 2 x-intercepts. Got it? Now, just because we just said x-intercept, I mean the axis of symmetry also in this case is 1, and here also it is 1. Between 2 and 1, the 2 and 0, we get 1 as axis of symmetry. So here we have another similarity, and that is axis of symmetry, right? Which is x equals to 1. For both the equations, axis of symmetry is x equals to 1. So these are three similarities between these two functions given to us, right? Now let's look into differences. So all these things, especially these two, we did even without calculations. Here you have to think a bit, right? So if there are two, you could avoid that. The idea is also to save time. Give the right answer, correct? Now, differences. So what are the differences? So if you look at it, we can see straightforward two differences. The first one is this function opens upwards. 2 is positive, and this function opens downward, right? So the f of x opens upwards, right? And this function opens down. So that is different, correct? The other we could say is about the y-intercept, right? So here the y-intercept is what? If I put x equals to 0, y-intercept is something which is very easy to calculate, right? So if I put 0, we find that the y-intercept is 0, 0 in this case. And here, if I put x equals to 0, what do I get? I get minus 1 squared, which is positive 1, times minus 1. I mean minus. So 2 minus 1. So at x equals to 0, the y value is 1, right? So their y-intercept is different. The other thing which you see is the vertical stretch. Here, the function is stretched by a factor of 2, vertically, upwards, right? So you could say, so that is the transformation, vertically stretched by a factor of 2. And here, it is not stretched at all, right? It is a reflection on the x-axis, correct? Which we said opens downwards. So you could say the function f of x is vertically stretched. And here it is not vertically stretched. We are comparing these functions with their base function f x square, y equals to x square. If you compare with y equals to x square, both these functions, so what we see here, that this function is not stretched vertically. However, this is vertically stretched by a factor of 2. But this function is reflected. This is not. So we are saying opens downwards and opens upwards. So we are already taken care of that part. So anyway, what I'm trying to say here is that you could write three differences even without doing any calculation. That's the whole idea, right? And of course, if you want to sketch these functions and then describe them, it all depends how many marks they are worth, right? So we could write this function as in factored form. Let me write it down. So if I take 2x common, I get here x minus 2. That means we have 2x intercept, right? The first one is at 0, the other one is at 2. And we have a parabola. Let me use this ink itself now. Okay. Kind of like this. Is it okay? For the other function, these are approximate sketches. We know this is 0 and this is 2. We didn't even calculate this point, but you could always write 1, which is the axis, and find this point, right? So if I write 1 here, then I get 2 minus 4, which is minus 2. So this point is minus 2. No harm. Okay. As far as the other function goes, the vertex is at 1, 2. So 1 and say 2. And it is opening downwards. This one is the stretched one. This is opening downwards. And the y-intercept we calculated was at 1. So we'll just use one value here and say it is kind of like this. Do you see that? So that is how these two functions are. So this is g of x for us. And the other one which you've drawn is f of x. So once you graph them, you can actually list very clearly a lot of differences and similarities. What we also saw is this x equals to 1 as axis of symmetry, correct? So that drawing very clearly indicates their similarities and differences. I hope that helps. You can subscribe to my videos and learn a lot. Thank you and all the best.